In this lesson, we're going to create two wheels and then connect the wheels with a tangent and try to figure out how far apart the centers are, which usually represents an axle or a chain or some kind that's going through two wheels or sprockets. So first thing we want to do is let's create a circle with a given size. We'll say this circle is over here, and I don't know, a radius of 3 units would be fine. Okay, and then what we'll do is we're going to create a point on the circumference, and any random point's fine. I'll put it up here at the top, and then we'll make the radius from it. So using a segment tool, we'll make that radius of the circle. Okay, now that would represent the first wheel, and now we're going to create a second wheel. The second wheel it's a little tricky to create, but the way you want to do it is you want to make this radius, you want to make another parallel line out here somewhere. So we'll just go ahead and use the parallel tool, parallel line. We'll select this line segment as our first one. It doesn't really matter where you put it, but maybe right about here if we're going to connect two wheels. And that'll give me a point that's going to represent the center of the circle, of the second circle. So now we have this and we have here. Let's go ahead and make the tangents. The tangents, one tangent actually. We'll pick point B. We'll go to the tangent tool, pick point B, and then the circle. That'll create the tangent. So now we have the first wheel, we have the radius and a tangent, and then we have the second wheel. So we want a point that intersects these two lines. Notice that the lines are perpendicular. That's good because tangents are always perpendicular to the radius. And so let's go ahead and make an intersecting point there. There we go, point D. Now I'm ready to make the second circle. The second circle will come from the center and a point. So we know the center is C, and then it'll go through point D. And there we go. So now if we were to move point B, you'll notice that the size of the second circle gets smaller, or it'll get bigger if I go the other way with point B. And that's because the two are connected through the parallel lines and the tangent line. The tangent line is perpendicular, the parallel line is the same distance apart. So that's what's controlling the second circle. Alright, so let's make the second circle a little smaller. And just to clean it up a bit, we'll hide some of these lines. We'll hide the perpendicular line using Control G. And then I'll go ahead and make the radius of the second circle using a line segment tool. And you can almost start to visualize that if this were two wheels of a machine or some kind of a bicycle type thing, where you have a bigger wheel and a smaller wheel, you can see that they're going to be, this outside might be the chain of maybe a dirt bike or something. We have a smaller sprocket to a bigger sprocket, and you can see how it's going to go round and round the two circles. So the tangent will almost be like the chain on the outside. But what we're interested in is the axle that goes from point C to point A. We actually are going to create a segment that goes from here to here. And the goal of this lesson is to say, if you have this situation, how do you figure out how long this is if you're given some information? You're usually given the radius of the circle. So let's go ahead and measure the circle. And we'll use a distance for that. Distance from A to B is 3 units, because that was the radius that we created. And the radius for here it is, distance from C to D is 1.3 units. And I'll just try to move that up a little bit. 1.3 units. Okay, so the key to this problem, and it's a common problem that shows up a lot, is you know it's making a quadrilateral on the inside. Let's just say that you're given the distance from B to D. So let's actually create a segment from B to D, from B to D. And then we'll go ahead and hide the tangent. So now we're looking at this segment, and let's say you're given D to B, that length. So let's go ahead and measure that length. B to D is 8.6 units. Alright, so now we have the 8.6, and the goal is to figure out how far is it from C to A, or A to C. The key lies in recognizing that there is a rectangle inside of that quadrilateral. It's not obvious when you look at it, but because this is a tangent, it makes a 90-degree angle here and a 90-degree angle there. We can confirm it by measuring the angle. So we can go measure angle B here, and there's the 90 degrees, and then you would also get this D is 90 degrees, and they have to be 90 degrees because they are tangents. Tangents are perpendicular to the radii. Let's clean this up a little bit. Okay, now we're ready to tackle the problem here. We want to know how far is it from C to A. We're going to get there indirectly. So the way we're going to get there is we're going to create a rectangle. The way we'll create a rectangle is we'll take C and we will make a congruent parallel line going over here. That'll give us the other side of the rectangle. So let's go ahead and do that now. To do that, we need to create a parallel line. So highlight this. Well, first go to the parallel line tool and highlight that. The point will go here, and you can already see the rectangle being formed there. And then we know that's 90 degrees. This will be 90 degrees. Now, if this whole thing is 3, if this entire radius is 3, and this one right here is 1.3, wouldn't this part of the rectangle also be 1.3? Isn't this 1.3 right here? And this is the 1.3. So if the entire radius is 3 and this is 1.3, wouldn't the other one have to be 1.7? So this bottom part of the triangle is 1.7 because the two of them add up to 3. Now let's take a look at this. Let's see how we're going to create this. It's going to be very straightforward now because we know that this part of the right triangle is 1.7. This part right here matches this one, 8.6. So we have a right triangle. 8.6 squared plus 1.7 squared is going to equal that missing distance squared. So this is what we're looking for. We're looking for the x right here. We need to know how long that is. So using a graphing calculator, we'll do exactly that. We'll take 8.6 quantity squared. We'll add that to the 1.7 squared. That'll equal x squared. And then we'll take the square root of that. So we'll take the square root of the answer, enter. And the other segment is about 8.77, we'll call it, 8.77, which is good. It's got to be longer than 8.6. This is the hypotenuse, so it would have to be longer than that. So the length of that x is 8.77 units. And that's a way to figure out missing pieces. And depending on what they gave you, maybe they gave you the hypotenuse and they're looking for this side, you would just work backwards with the Pythagorean theorem. So that's another application of tangents, and in this case you're applying it to two wheels.